So we're going to be discussing factorials and permutations. We'll start with factorials and then we'll go through permutations after. So a factorial is something that looks like this. It looks like 6 and an exclamation mark. And that's actually the mathematical symbol for a factorial. And what it means is, it means 6 times 5 times 4 times 3 times 2 times 1, which is 30, 120, 360, which is actually 720. If you had 3 factorial, that would be 3 times 2 times 1, which would be 6. That was pretty straightforward. If you had 10 factorial, that would be 10 times 9 times 8 times 7 times 6. That might be a while. So it might be useful to be able to do it now. So most calculators will have, so you're going to look for a button, and every calculator will be different. So it might look like this or like this. Some calculators, I think, have it hidden behind a probability button, and it's just an exclamation mark. But either way, try to find your button, and if not, you could go online and look up where your factorial button is. Mine happens to be a second function over there, so I would type in 10 factorial, and it would give me a big number. So it's going to give me 362,880. So 3,628,800. Fairly large. And they get big really quickly, by the way. I think the biggest one your calculator could handle, like 70 factorial, is already beyond what your calculator could do. 2 factorial is 2 times 1, which is 2. 1 factorial is 1. And 0 factorial is a little bit weird. 0 factorial is just defined as being equal to 1. So 0 factorial is just equal to 1. For no explained reason, it's just defined as such. So 0 factorial is 1. Okay. So let's see when we might use this. You are inviting six friends to a party of some sort. And how many different orders can you call or text, whatever. We'll say call. Call your friends. We're gonna do this the old-fashioned way and call people because we have that. So we have our friends, and I'm going to think of them as being A, B. We're going to call them A, B, C, D, E, and F. So Abby, Bertha, Corey, David, Eve, Francis. 6 friends. And we want to figure out how many different ways are there to call our friends. So we're going to make a tree diagram out of this. So the tree diagram is going to be, start off with a dot. And it's going to be, so the first one we actually could call all 6 of them. So there's 6 options for the first person to call. For the second person to call, we've already called somebody first. So this is one of those decreasing ones where we have a pool and there's fewer of them left each time we call. So it'd be 6, then there's going to be 5. And then there's going to be 4 people to call, and then 3 people to call, right? So for each of those, there's 5. And then for each of those, there's 3, 4, and then for each of those, there's 3, and then for each of those, there's 2, and then 1. 6, 5, 4, 3, 2, 1. And for a tree diagram, what we do is we multiply it, and we get 6 times 5, that ends up being 720. Now, another way of writing this, of course, would be to write it as 6 factorial. So the number of orders to line up 6 things would be 6 factorial. Now let's say instead of inviting 6 friends to the party, I would be inviting, let's say I'm inviting 8 friends to the party. So that'd be the same thing, except it would be 8, I did this on top, 8, 7, 6, 5, 4, 3, 2, 1. Or to put it another way, it would be 8 factorial, which would be 8 factorial, which is 40,000, sorry. So there's 40,320 ways to invite 8 friends, and 7 friends would be 7 factorial, and 5 friends would be 5 factorial. And if you had no friends, there'd be 1 way to invite nobody. Now what we're going to do is for the next video, we're going to kind of play around with that a bit.